Hello guys, I am Ranjan Mishra from Revolution Physics Ghaziabad. Today let's discuss a question of IITJEE main on that is asked on 26th Feb 2022. Question is, if C and V represents capacitance and voltage respectively, then what are the dimensions of lambda where lambda equal to C upon V? Okay, let's discuss. Here is lambda equal to C upon V, but we know that Q equal to CV, so we can write C equal to Q upon V. So this lambda reduces to Q upon V square. Just put the value of C, it becomes Q upon V square. But also know that V equal to work done per unit charge. Okay, so it reduces to Q upon W square into Q square. So it becomes Q cube upon W. W is nothing but force into displacement whole square. Now we know that Q equal to IT and dimension of force equal to ML T minus 2, and this is L, and now it is squared, so it becomes I cube T cube upon M square, and this L square to the square, it becomes L to the power 4 and T to the power minus 4. Okay, now lambda equal to, put all these in bracket. Okay, this is M square, so it becomes M to the power minus 2. Here is L to the power 4, it becomes L to the power minus 4, and here is minus 4 and here is plus 3, so it becomes T to the power 7 and I cube. This is the answer. Okay, thank you. This is a hybrid question of electrostatics and Newton dimension. Thank you. Next question is, again this is from JEE Mains, 24th Feb in first shift. Okay, two equal capacitors are first connected in series and then in parallel, the ratio of equivalent capacities in two cases. We know that if two capacitors are connected in series, let it be C1 and C2. So C equivalent in series will be C1 C2 upon C1 plus C2, because two equal capacitors both are equal, so it will be C into C upon 2C, so it becomes C by 2. Okay, that means when it is connected in series, so CS will be C by 2, and when it is connected in parallel, we know that it will be C1 plus C2, both are equal, so it will be 2C. C parallel will be 2C. Now we have to calculate the ratio Cs upon Cp, so it will be C by 2 into 2C, so it will be 1:4. That means Cs upon Cp will be equal to 1/4. That means answer will be 1/4. Okay, thank you. Hello guys, I am Ranjan Mishra, and let's discuss the question of capacitor that has been asked in IIT JEE on 31st August 2021. Okay, question is, calculate the change in electric energy stored in the capacitor when a medium of dielectric constant K is introduced between the plates of capacitor. The capacitance of capacitor is 200 microfarad and is connected across a 200 volt source. We know that if there is a capacitor and it have a value C naught, let's say it have a value C naught, and it is connected to a supply. When the medium between the capacitor is filled with a dielectric of dielectric constant K, then new capacitance becomes K times C naught. This is the basic concept that we are going to use in this question. That is, question is, there is a capacitor and it is connected to a supply. Its value is 200 volt and its value is, let us say, C. Then the initial energy stored will be half CV square. Okay. Now, if I fill this medium with a dielectric constant K, then the final energy becomes half K CV square, because just capacity increases by K times. Okay, so change in energy stored will be E final minus E initial, and just put the value half K CV square minus half CV square. Half CV square is taken common, so here will be K and here will be minus 1. This is the change in energy. Okay, now put the values. Half C is 200 micro, that means 10 to the power minus 6, and V square, V is 200 volt, that means 200 into 200, half CV square, and K minus 1, K is 2, that is 2 minus 1, it will be 1. Okay, now it will be 100 and it becomes 2, 2, 4, into 20, 20 and 20, it is 60, 10 to the power 6 into, here is 10 to the power minus 6, so it becomes 4 joule. Okay, so answer of this question will be 4 joule. Thank you. Hello guys, I am Ranjan Mishra. Let's discuss a question of JEE Main 2021 asked on August 27 in Shift 2. Question is, in the given circuit, if C1 and C2 and C3, C1, C2 and C3, find the ratio of charge on capacitor C1 and C2 at a steady state. This is a very simple question, as we know that if this charge Q1 is supplied by this voltage source, then at this junction charge must divide, because there is two ways. Okay, let it is Q1 and let it is Q2. Now the same charge Q2 will flow in Q3. So charge C2 and C3 are in series. So if I redraw this circuit will be like this, and the equivalent of C2 and C3 will be C2 C3 upon C2 plus C3, let it C dash, because in series circuit the equivalent capacitance is 1 upon C1 plus 1 upon C2 equal to 1 upon C equivalent. So I applied series formula for C2 and C3. Okay, and this is C1, and here is the supply V. Now this arm and this arm, the upper arm and lower arm are in parallel, because charge is dividing here. Q1 and Q2 charge is dividing in two arms, so these two arms are in parallel, and so voltage will be same. Okay, now come to the question, find the ratio of charge on C1. Okay, charge on C1 upon charge on C2, and we know that Q equal to CV, that means it will be C dash V upon C1 is not C dash, it is C1 V upon C dash V. Okay, V and V will be cancel out, so it is C1 upon C dash, and C dash is C1 upon C dash is C2 C3, and it will be C2 plus C3. Just put the value. C1 is 2 and C2 is 6 and C3 is 12, and it's 6 and 12. Okay, it will be 6, and this is 6 plus 12 18, so it will go and it becomes 1 by 2. So QC1 upon QC2 will be 1 by 2. It's very easy question. You have to just apply the basic concept of distribution of charge and the basic concept that in parallel circuit voltage is same. Okay, thank you. Hello guys, I am Ranjan Mishra, and today we have a question of electromagnetic wave. Direct question, simple question. I think question cannot be simple, or it cannot be simpler from this question. Just you have to use the formula. Okay, question is, if electric field of 6 volt per meter is present in a region, then magnetic field will be. Okay. As we know that direct formula, C equal to E upon B. This is the magnitude of electric field. This is magnitude of magnetic field. So just put the value and you will get magnetic field. It will be E by C. C is speed of light and E is given. E is 6 and E is 3 into 10 to the power 8 meter per second. Okay. So 3 2s are, it will be 2 into 10 to the power minus 8 Tesla. Okay. Option C is correct. From this formula, one thing is also very clear. In light, the dominant part is electric field. You can see electric field is 6 volt, but magnetic field is in range of 10 to the power minus 8. So from this formula we can say that E equal to C times B. That is, electric field is 3 into 10 to the power 8 times to the magnitude of magnetic field. That means main part or major part of light is electric field. So when this, in most of the time in discussing light, we take light as a electric field vector. Okay, thank you.